All right, we're going to be solving rational equations today. I can hear you clapping and excited. All right. We're going to need to make it quiet, though, and get started. All right, here we go. Let's compare something before we begin anything. Let's talk about something you already know. Remember when we had x squared equals 9? What it's asking you is what number, when I square it, will give me 9? So what number when I square it gives me 9? 3, right? 3, when I square it, it gives me 9. So x equals 3 is the solution, all right? But isn't there another solution here too? What other number when I square it gives me a 9? Negative 3. Did this back in the day. So negative 3 squared is also a 9. So x is equal to negative 3 also. But let's talk about x to the third equals 27. What number, when I take it to the third power, gives me 27? All right, so 2 to the third is 8. 1 to the third is 1, so I didn't even think about that one. 3 to the third is 27, right? 3 times 3 times 3, 27. So we know that 3 to the third is 27. All right, so in this equation, x must equal 3. Well, isn't it like the other one? Like, can't we just say negative 3 also? Well, we can't, because when we do negative 3 in parentheses to the third, what happens here? You get negative 27. So that one's not going to work. So we only have one solution to this. So basically what we're going to do today, if we have x squared equals 9, to get rid of a square, you take the square root. But when you take the square root of something, you have to remember your plus and minus. Okay? So that's why we have two answers there. And by the way, we're always going to check our answers really quickly in the calculator, and then we'll get A pluses on our quizzes and our tests. So on the second one here, if I have x to the third equals 27, how do you undo a cube? Well, you take the cube root. But when you take the cube root here, you don't have to worry about a plus or minus ever. Okay, so it's just going to be x equals 3. So that's how we're going to be doing them today, but I wanted to kind of touch base with you there because there's usually some confusion there with students. So let's go to this little box down here. When we take the even root of something, here we took a square root, so we could take a square root, a fourth root, a sixth root, an eighth root, etc. When we take an even root of something, we will have two solutions, okay? Sometimes you may get incorrect ones, so that's why we're going to check our answers, but, you know, you could get two solutions. When we take the odd root of something, okay, we will have one solution, okay? I would always check my answers, but you absolutely have to check your answers with even roots. So that's all fine and dandy up there, but that's some old school stuff. So we're getting into some new school stuff today, and we're going to be working with fractions as our exponents, which everybody loves. Very challenging and nice. So looking at this, how do I know what is the root? So 4 to the 5/6 is this. So if you remember this, that's what it looks like. Now, I don't want you to sit there and transfer everything into that. That would waste a lot of time. So just look at what happened there. The 6 was in the denominator. The denominator is the root. Okay, the 6 was in the denominator, so the denominator is the root. All right, so if our denominator is even, we put a plus or minus. So if the denominator is even, we're going to use the plus or minus. There's two solutions, okay? So we gotta keep this in mind as we work through them. So let's look at number 1. So we wanna isolate whatever has the exponent on it there, right? And the variable, obviously. So we're gonna subtract 9 from both sides. So x to the 2/3, 34 minus 9 is 25. Okay, we have to get rid of the 2/3, and that's really crazy looking, right? And a lot of students get stuck right here, but how would you get rid of a 2/3 like if it was an equation? Like say we have 2/3 x equals 1, right? You would multiply by the reciprocal. So we're kind of going to do that here. We're going to take it to the power that is a reciprocal of it. So I'm going to write this way so you can see what's actually going to be happening here. So here's everything we already have. And what we're going to do is we're going to take it to the reciprocal power. And what happens there is, what's 2/3 times 3/2? It's 1. So peace out, goodbye. We just have an x. Now pause here for a moment Did you take an even or an odd root? Look at the denominator. Right there, right? This is an even root. This is an even root. So when you did this, you need your plus or minus. Now, I tend to go to the calculator and type stuff in. Just double check it this way. Let's see if we can see if it's anything. 125. Look how pretty that is. So we have plus or minus 125. Now, remember what I said. You have to check your answer, and it doesn't have to be anything tedious. See this original equation here? I'm going to check the positive 125 in the original equation. So we've got 125 to the, was it 2/3 there? Yeah. To the 2/3 plus 9. Now, that should give me 34. If it gives me 34, we're all good. Boom. It gave me 34. So now I'm going to do the same thing, except what I'm going to do is I'm going to put my negative 125 in instead of positive 125. So I'm going to go over here. I'm going to insert a negative. Boom, 34 again. So both of those work. They both check. I'll put 2 checks there as if I checked it. All right, and they both work. I'm telling you right now, sometimes they're not going to work, so always check your answer. You don't want to miss the problem. So let's look at number 2. This 1/3's on the whole shebang here. The whole entire expression that 1/3's on. So let's get rid of it. Remember, to get rid of it, we're going to take it to the reciprocal power. So I already have 2x plus 1 all to the 1/3, right? And we want to take it to the reciprocal power. So this is going to be to the 3/1. Okay, 1/3 times 3/1 is 1, so goodbye, see you later. And we have to ask ourselves, hold up, was this an even root? Look in the denominator, we have a 1. This is an odd root, so you do not need the plus or minus. You do not need the plus or minus. And we might as well do 5 to the, now 3/1 is 3, so I'm just going to do 5 to the 3rd. So we get 125. No plus or minus because it's an odd root. Subtract my 1. And then we divide by 2, and we get 62. Now, you should check your answer always to make sure that you have the right answer so you can get those A pluses going on. But I know that this one works. All right, so let's keep it going. Right here, well, now we have radicals instead of fractional exponents, but we know that radicals and fractional exponents are all the same deal, right? So you can change this to a fractional exponent if you want to. If you want to work on it this way, to the 1/3 equals 5, you can do that. I just know that the inverse of a cube root, is taking it to the 3rd power, right? Those undo each other, they're inverses. Now, this is 3/1, right? So this is an odd root, so you don't worry about a plus or minus. So 5x plus 10 equals 5 to the 3rd, which is 125. Okay, now if this confuses you, go ahead and write it as a fractional exponent. It's completely fine. All right, subtract our 10. Well, we have 115, and then we divide by 5. I should be able to do that in my head, but for time's sake, 23, and we're all done. You should check your answer. Just make sure you got it right, but I know that that one's right, so I'm going to kind of skip over that because I just know, but you should check it. All right, over here, do you notice this plus 8 right here is not under the radical? So let's just get him out of there, all right? So let's subtract 8 from both sides first. He's not part of the team over here underneath the radical, so this would be -4. Now, this is a square root. To undo a square root, you take it to the 2nd power. If you get confused by this, you are more than welcome to rewrite it as this. And you know what? I'm just going to do it this way because I didn't do it that way on the other one. So I'll just switch it up on this one and show you can do it this way. So if I write it this way, take it to the 2/1 power, take it to the 2/1 power. These guys will cancel out here. We'll have 4x plus 8 equals -4. Look, that's an odd root. No plus or minus, right? It's awesome. Odd root. Okay, so this will be 16. Then I subtract my 8. And I divide by 4 and I get a 2. All right? Now, you should be checking your answers. Remember, the other 2 I said worked, but you definitely should be checking your answers here because what happens? What happens here? I'm going to go ahead and check it the long way and show you what happens. So we've got 4 times 2 plus 8, and we want to know, does that equal 4? Well, 4 times 2 is 8, and 8 plus 8 is 16. So is the square root of 16 plus 8 equal to 4? Is 4 plus 8 equal to 4? No way, not at all. Okay, so this actually did not work. So this is no solution. Okay, no solution. Always check these guys out. Always check them out. I'm telling you, check all of your answers. The only reason I didn't do it on the other ones is, you know, for time's sake, you know, I just didn't want to take up time with it. So that one is no solution. So those will happen sometimes. If you forget to check your answer, you're gonna miss the problem. All right, let's move down to number 5. Last one here. This one's kind of weird. We already have the radical isolated. So if it's square root, I can square both sides. Now, some of you like to do some real crazy stuff with this, but just remember that this is x plus 2 times x plus 2. And this square will undo this square root right here, so we'll have 9x. You want to multiply these guys out. Some people call it foiling. I don't like to call it that, but you go ahead and use the distributive property and multiply those out. And then this is what we'll get. And then we'll clean up all those like terms. Now, by the way, if I'm going too fast, pause me. I personally will watch the whole video and then go back and watch it a second time and take the notes the second time. That's just how I learn. So x squared plus 4x plus 4 equals 9x. All right, if I subtract 9x from both sides, I have x squared minus 5x plus 4 equals 0. Okay, what multiplies to give you 4, but adds to give you a negative 5? X minus 4, x minus 1 equals 0. There we go. And then if I take each one of these and use the zero product property, ZPP if you will, you set each one equal to 0, and then you solve. So x equals 4 and x equals 1. And remember what I said, will you please check your answers? Check your answers. Now you can do it on the calculator if you want, but I'm going to kind of just check it here. So is 4 plus 2 equal to the square root of 9 times 4? All right, so is 6 equal to the square root of 36? Yes, sirree, it is. We're good to go. Then I'll check the 1. Is 1 plus 2 equal to the square root of 9 times 1? Is 3 equal to the square root of 9? Yes, it is. So this guy and this guy are good to go. Those are our answers. So I hope you thoroughly enjoyed today's lesson, and I hope you're ready to come to class and just bust out some of these equations and get the right answers. And we're never ever going to forget that we have to check our answers. Okay? So until I see you guys again, goodbye.